All right, so let's try to integrate a little bit of fractions into our shapes. So if I've got two congruent squares, congruent meaning equal, they're the same, even though Miss Podlasky didn't draw them exactly perfect, just trust me, they're congruent, all right? So if I've got two congruent squares and I divide one square into two triangles, all right? And I divide the other square into two rectangles, okie dokie. Then what fraction is each triangle? For just this one square, right? I've cut my square into two parts. And here's one part and one part. So I've cut my square in half. Think about it like a sandwich, right? I cut my sandwich in half. Perfect. Now what about this? Is that the same fraction? Sure it is. I've got two parts and one rectangle here and one rectangle here. So I've cut my rectangle, or I've cut my square in half also. So they represent the same amount. They both represent half, even whether I cut it into rectangles or I cut it into triangles. Now, if you see your congruent squares like this and somebody asks you for the area, can you give it to them? No, I don't have any numbers. Can you give them the perimeter? No, I don't have any numbers, right? So don't be tricked. Sometimes on tests or quizzes, there might be blank squares and it says, oh, well, the area is the same, or the perimeter, or this or that. If they don't give you numbers, don't fall for that trick. Cross those out. Process of elimination, that's not what we're talking about. Most likely, we're going to be talking about fractions because that I can always draw on an empty square, right? Fourths would look like that. If I cut a square into fourths, what if I cut my square into fourths with triangles? There we go. So, if a question on a test asks you to cut your congruent squares in half, or to separate them using two parts, rectangles or triangles, that's half of one whole. 2 halves of one whole.